In this chapter, we're going to be introducing hypothesis testing. This is what this entire class has been leading up to. We've been developing all the tools that are necessary in order to do hypothesis testing. And pretty much the rest of this course will be some sort of version of hypothesis testing. Our approach to the rest of this course is going to be very systematic. Okay. In fact, there's going to be a 6-step process in order to do a hypothesis testing problem. And we'll go over that in the next section. But for now, we're just going to talk about the basics of hypothesis testing. So the objectives today are to determine the null and alternative hypothesis, so we'll define what those are, explain what a type 1 and type 2 error is, and then also state some sort of conclusion to our hypothesis test. Now, in the previous chapter, we talked about estimation, right? Well, we came up with confidence intervals for some sort of population parameter. Now, in this section, hypothesis testing, well, it's the process of using sample data in order to test a certain claim about the value of a population parameter. Okay, and we'll talk about a few examples in this section. All right, so the next 3 sections are all going to be dealing with hypothesis testing regarding a certain population parameter on the mean, the proportion, and the standard deviation. Okay, one section for each parameter. Well, oftentimes the first time you hear the word hypothesis is when? Well, when you're talking about the scientific method back in middle school or so. And what was a hypothesis? Well, it's a certain statement or claim regarding the characteristic of one or more populations, at least in the context of what we're doing. So in the scientific method, we always started off with some sort of hypothesis, right? Some sort of guess at what we believe is the explanation or the true answer of what we see. So a few examples of hypothesis or statements or claims are the following. One claim statement for each of the following sections that we're going to talk about in the next 3 sections. Okay. So in the next section, the type of claims that we are going to see are claims on a proportion. Okay. So here's an example. The proportion of females at this college is more than 0.5, or the proportion is greater than 0.5. Okay, that is a claim, correct? So it has to be substantiated by some sort of evidence, right? You can't just make a claim without proving it, right? And that's what we're going to do. Here's another claim about, in this case, the mean. The mean amount of soda in a bottle is 20 ounces. Again, that is a claim. It has to be substantiated by some sort of evidence. And the third one is a claim on a standard deviation. The standard deviation of heights of supermodels is less than 2.6 inches. Okay, and here's the mathematical symbols for each one of those claims. So you see how that sentence is all encapsulated in each one of these, either an inequality or an equality mathematical symbol. Okay, so we're going to have to try to develop that habit of being able to read something like that and automatically figuring out, okay, what are we talking about? Proportion, a mean, or a standard deviation? And also what to use as far as the mathematical symbol and formulate it in this way. So that's a hypothesis, right? Now, hypothesis testing is a procedure based on a sample evidence and probability used to test statements regarding a characteristic of one or more populations, right? That's why we talked about probability before we started talking about hypothesis testing, because we're going to use everything we've learned so far. Now, one thing to note is that if you actually had access to all the population data, then there would actually be no need for inferential statistics. Inferential statistics being coming up with confidence intervals or this hypothesis testing. Because if you have all the population data, then there's no variation in what the proportion is or the mean is or standard deviation, because you would just calculate from the data, and there's no wiggle room there, right? There's no doubt what the value is, okay? There's only doubt when you don't have access to all the population data, but instead you're sampling from the population, okay? And there's a little bit of doubt in that sample because we obviously don't have access to all the population data. So there's still a little bit of doubt. That's why we have to use inferential statistics. Okay, so to reiterate, hypothesis testing, a statement or a claim is made regarding the nature of a population, and then sample data is collected to test that statement, and then data are analyzed to assess the plausibility of that statement. Now, a claim is made, correct? Now, that claim can either be true or false. Okay. Now, hypothesis testing is based on two types of hypothesis, and that is the null hypothesis and the alternative hypothesis. Okay, so these are all new terms for us, so let's go ahead and define them. So the null hypothesis is a statement of no change, no effect, no difference, no relationship, and it's assumed to be true until evidence indicates otherwise. Okay, we denote this with this symbol, H sub 0. Okay, null typically means 0, so null hypothesis. We always have the equal symbol in this statement. Okay, that's good to know because that's going to be used throughout the course. This sometimes can be thought of as the status quo statement. Okay, the null hypothesis is just we believe something's true because it's always been true until there might be some evidence to indicate otherwise. Okay, the null hypothesis is assumed to be true until we have evidence to the contrary. Now, the alternative hypothesis is some sort of hypothesis that challenges the null hypothesis or challenges the status quo. It is a statement of some change that has occurred differing from the original circumstances. So the alternative hypothesis is a statement that we are trying to find evidence to support. Okay. We denote this as H1, H sub 1. Okay. Some textbooks also call it HA for alternative. So we have null hypothesis, which is HO, and alternative, it's H1. The textbook I'm using uses H1. Okay, so this statement will always either have an not equal symbol, a less than symbol, or a greater than symbol. Okay. The null hypothesis is easy because it's always going to have an equal sign. And the alternative is any of those three. Now, there are different types of null hypothesis and alternative hypothesis pairs, depending on the statement and claim. Okay, we have three kinds, as I'll state right now. There's a two-tailed test, there's a left-tailed test, and there's a right-tailed test. In the two-tailed test, we test whether the parameter is equal to versus not equal to. So equal to versus not equal to, equal to versus not equal to. So we have some sort of parameter. It could be the mu, it can be the proportion, it can be the standard deviation is equal to some sort of number. And the alternative is that that parameter is not equal to that same value. Some of the key words to look for in these problems that deal with two-tailed test are not equal to, differs, is different, has changed, is not, ... Okay. A left-tailed test tests whether the parameter is equal to versus less than some sort of value. Again, it's the same parameters. In this first few sections, we're going to talk about mu, proportion, standard deviation is equal to some number or less than that number. Again, the null hypothesis always has the equality here. Okay. Now, keywords that are synonymous with less than are, well, decreased, smaller, less than, fewer, and there's many other examples, of course. A right-tailed test is greater than, right? So that's the symbol that we're using. It's the same idea. We have some sort of parameter, whether it's mu, proportion, or the standard deviation. And again, the keywords that are synonymous with greater than are the following: increased, bigger than, more than, larger, exceeds, and of course there's many more. Now, throughout this process, we are identifying some sort of hypothesis statement, some sort of claim, right? And then we set up the null hypothesis and the alternative hypothesis. And we collect the data analyze data, and we have to come up with some sort of conclusion. Okay. So again, we haven't gone through the specifics of all that yet. We will in the next couple sections. But once we're at the end and we came up with some sort of conclusion, now how do we state these conclusions to hypothesis tests? Okay, well, at the end of the day, we either are rejecting the null hypothesis if we have enough evidence, right? Or we don't reject it, right? We fail to reject it. Okay, and we're always testing the null hypothesis, whether that was a claim or not. Okay, we always put that null hypothesis to the test, right? And that's what science is all about, really. There's a status quo understanding of some sort of situation. We continue to gather evidence throughout time to see if that prevailing theory still holds up. Now, what we don't do is we never accept the null hypothesis, okay? It's always being put up to the test, okay? A scientific theory is never really accepted. It's just not rejected. That's what we're saying, okay? We just say it's still a scientific theory backed up by evidence, but it's not really accepted. We just haven't had enough evidence to reject it yet. So scientific theories have to hold up over time, right? In a way, be accepted, right? But technically, they're never really accepted, right? Because they always have to be held up to scrutiny. So we never accept the null hypothesis because without having access to the entire population, we don't know the exact value of the parameter stated in the null hypothesis. Okay. Rather, we say that we do not reject the null hypothesis. Okay, so let me reiterate. To not reject the null hypothesis does not mean that the null hypothesis is true. It just means that there is not enough evidence to reject it. Okay. So just like in the court system, we never declare a defendant to be innocent, but rather we say that the defendant is not guilty. Okay. Now this whole innocent versus not guilty is an important concept. Innocent is not the same as not guilty, right? Innocent is when the person did not commit the crime, whereas not guilty is when there is not enough evidence to convict. Okay, so once we come up with some sort of conclusion, right, whether we reject the null hypothesis or we don't, well, that can lead into making errors. There's a chance an error can occur. So we have to come up with a way to minimize these types of errors, okay? Now, there's two types, okay? There's a type 1 error and there's a type 2 error, okay? What we mostly focus on in this course is a type 1 error. That seems to be the worst error of the two types, okay? All right, so this little table summarizes the types of errors that can happen, and I'm going to use that innocent versus guilty example to illustrate this, okay? So, in reality, somebody could be innocent, right, of a crime. Let's say it's a crime, right? Let's say it's murder, okay? Somebody could be innocent of that. That means they truly did not do it, right? So only they really know, right? Okay, so that is what we mean by we are innocent until proven guilty. So we say we are innocent until proven guilty, right, in reality. But let's say the reality is that this person is guilty. This person did commit the crime, right? But for now, we assume they're innocent until we have evidence to prove otherwise. Okay, so that's what we mean by the null hypothesis being true. They're innocent. Or in reality, they are guilty. So that would mean that the alternative is true. Okay. So I guess I can write up here, null hypothesis is that you're innocent. And the alternative is that, well, we're challenging your innocence. We're saying that you're guilty. In reality, you're either innocent or guilty, right? But what happens? Well, we make some sort of conclusion based on the evidence, right? Well, if we do not reject the null hypothesis, then that's the same as saying not guilty. Okay? And if we reject the null hypothesis, meaning we reject that they're innocent, that means we had some sort of evidence to suggest that this person was guilty, right? Those are the conclusions, right? These conclusions can be these things here. So that's what that means. So obviously an error could occur, right? Now let's look at this first thing here, this first table here. Well, if the person is innocent and the results of the trial were that they were not guilty, then that was the correct conclusion, right? So good job for that, right? Okay, well, what other way can we have a correct conclusion? Well, if the person was in reality guilty and we actually had enough evidence to make that decision that was being made, right? That was their decision. That's either being guilty or not guilty. Then again, that would also be the correct conclusion, right? Now, the other two are where we commit errors, okay? Let's say a person was innocent and somehow there was enough evidence, maybe a really aggressive lawyer, they found some sort of way to prove that they were guilty, right? That would be considered a type 1 error. Okay. Now, a type 2 error would be, well, if the person is guilty and there wasn't enough evidence to prove that they were guilty, we say that they're not guilty. That was the conclusion there, right? That's another type error. So this person got away with murder. Got away with murder. A type 1 error would be innocent person goes to jail, goes to prison. Okay. Now, which one of these errors is more serious than the other? They're both two bad errors, right? But typically, in most situations, a type 1 error is a worse decision to make, right? People get away with all sorts of things all the time, right? But to actually have evidence to suggest an innocent person who is truly innocent to be guilty, right? That's a really bad error, right? That's a systematic problem, right? So that's technically a worse error to make, okay? Because there shouldn't be evidence to suggest an innocent person is guilty, right? So that is what we call a type 1 error. That's a more serious problem. That's more of a systematic problem, okay? So, type 1 error. If we reject the null hypothesis when the null hypothesis is true. Okay, so that's what a type 1 error. We reject the null hypothesis when the null hypothesis is true. Okay, we reject that they're innocent when in fact they are innocent. Okay, type 2 error. We do not reject the null hypothesis when the alternative hypothesis is true. So, we say that they are not guilty when they were actually guilty. Okay. So those are the two types of errors. Okay. And again, the type 1 error is the one that we focus on in this course. Now we're going to talk about the probability of making a type 1 error and a type 2 error. Okay. Now, the level of significance, which we'll denote it with alpha, is the probability of making a type 1 error. Okay, so that's very important. That's because we're going to use that all the time. So the researcher chooses an alpha before the sample data is collected. What is our level of significance really? Okay, well, that's our willingness to commit a type 1 error. Okay, because we can never really have our error probability be 0, right? Because there's always a chance of making an error, but we want to minimize it as much as possible. Typical values that are used for alpha is sometimes we use a 1% probability of making a type 1 error. Sometimes we use 0.05. Sometimes we go up to even 10%. The more serious the issue, the lower the alpha should be, okay? And a lot of these examples that we're going to do in this class aren't going to be like really serious questions. We're going to talk about like, there's a claim that the percentage of brown M&Ms is 13%. That's not a real serious problem. So an alpha for that would probably, a 10%, even a 15% might be okay with that, right? Because committing a type 1 error in that decision isn't as serious as other types of questions. Kind of like the effectiveness of a certain drug, right? Usually those things done in clinical trials use like alphas of 0.01 or something like that. Okay. Now type 2 error is denoted with beta. We're not really going to use that throughout this course, but in courses beyond the basics of statistics, they do talk a lot about type 2 errors. Okay. So we're going to go ahead and now see how this is applied to the three population parameters in the next three sections, which are the proportion, the mean, and the standard deviation.